on the board, we've got all of the formulas we've worked out so far for exponential and log functions. So we've seen that the derivative of e to the x is e to the x. And in the last video, we looked at the inverse function. We saw that the derivative of the natural log of x was 1 over x. We also saw that the derivative of the natural log of the absolute value of x was 1 over x. That's going to be fairly useful a little bit later on this section. It's also going to be very useful when we get to the part of the semester where we start with a function and then say, what is this the derivative of? Because if I start with 1 over x and say, what's it the derivative of, this answer is wrong. Because 1 over x is defined as long as x isn't 0, but this is only defined if x is positive. This is the function whose derivative is 1 over x, defined on its entire natural domain, all non-zero numbers. Okay, we also know that if I take the derivative of an exponential function with a different base, I still get that exponential function back, but I multiply by the natural log of the base. If my base is e, the natural log of e is just 1, and we don't usually write that we're multiplying it by 1. What we haven't looked at is what's the derivative of b, the log base b of x. Well, if I have y equals the log base b of x, I'm going to use the same trick that I used for the natural log of x. I'm going to say that's the inverse of y equals b to the x. So what this means is that x is b to the y. And now I can use implicit differentiation. So I would say the derivative with respect to x of x is equal to the derivative with respect to x of b to the y. 1 is what I get on the left side. On the right side, we get the natural log of the base times the original exponential function, b to the y, times the derivative of that inside part, y prime. And so we get that y prime is 1 over the natural log of the base times b to the y. That's giving me my formula for the derivative in terms of y. But remember, b to the y was just a fancy way of writing x. So I can say y prime is the reciprocal of the natural log of the base times x. So it's a very nice pattern. If I have an exponential function, when I take the derivative, I get the exponential function back. If the base is some number other than e, I get an extra factor of the natural log of that base. If I have a log function, when I take the derivative, I get a reciprocal. I get 1 over x. If the base is some number other than e, I get an extra factor of the natural log of the base. This time it's just in the denominator. Okay. Now, of course, the domain of any log function is just positive numbers. So although this function is defined for everything non-zero, it's only the derivative of this if x is positive. I could do something similar with taking the derivative of the log base b of the absolute value of x. We're mostly going to work, if we need the absolute value, we're just going to work with base e. So this is the only formula that we'll really need there, although we could generalize that with the base of b as well. Okay. But all of the formulas on the board now, you want to add to the list of formulas that you know, and you should also know how to derive the derivatives of the log functions. So you can use implicit differentiation for finding the derivative of a log function, just like you did for the inverse trig functions. And then for the derivative of the natural log of the absolute value of x, the key was to write that as a piecewise function, writing the absolute value of x as x if x is positive, and the opposite of x if x is negative.